October 14th, 2015. You're looking at amazing images from the Solar Dynamics Observatory. Now, this is Earth-facing, and we're seeing a camera. This is actually called the AIA 171, or the gold camera, and it gives you a unique look at the magnetic lines of force that are surrounding the sun, much as they are surrounding the Earth. Here, they're more visible because of what we're dealing with as far as surface. Now, at the top left, you see the coronal mass ejection from the filament eruption that occurred yesterday. After this collapse, just below the the sunspot we're watching, you can see a burst of energy. Now, that's important right there, guys, because of the amount of plasma that was in that particular burst. Now, this sunspot has went from a 1% chance of X flares to a 5% chance, and it's just barely turning our way. That could change very quickly. Now, as we look at it, you notice that this is just south of the equator of the sun. So is the planet Earth, where we're sitting. We're not completely equal with that equator or the ecliptic. We're slightly south of that particular line. So that makes it what they call more geo-effective if you have a burst. Now check this out. Same satellite, different camera. Again, what caught my eye was the amount of plasma that had been ejected from the surface of the sun. Now, I did a video back in February of 2014 called a kill shot video to show that this amount of plasma can be hurled far out into space, even further than our planet. Again, we'll take a look at that, but many of you remember the video that have been watching the channel now for several years. It was called a kill shot, and it was amazing. It was before stereo A and B went behind the sun. We have not regained connection with stereo B. Remember the video yesterday? A is peeking back behind it, but notice in the bottom left, stereo B, that was February 2014. As we see this eruption, that tiny ball you see at that line is our planet. Look at the material ejected from the CME. Again, you're looking at the planet Earth from stereo B. It is at this time following Earth in its orbit. Now, it just so happened that it's now behind the sun and cannot broadcast. Very important satellite. Even though the optics had been damaged somewhat, it still gave us very good images, especially with this camera. Look at the amount of density, much larger than our planet, that passed just in front of the orbit during that coronal mass ejection. That's how far these eruptions can travel. It's amazing images. This is the sunspot, and it's the one that's causing this trouble. This is what it did if you look at it from SOHO. Again, different satellite, but Earth-facing images also. Again, remember the size of what we're dealing with here. LASCO C3, same camera, much wider view. This is the eruption that we're dealing with now. The top left, bottom left. Bottom left, again, would be more geo-effective. As this sunspot turns, this will be spreading out to the left. We could get a glancing blow from this in a couple days. But the problem would be if that type of activity continues as it rotates towards our planet. It takes about 14 days for one of these sunspots, guys, to go across the surface of the sun as far as what we can see from edge to edge. It's a 27-day rotation period. Now, look at our shields during this time. Notice the timestamp, yesterday and today. That tells you that Cern is running wide open, and they have been. They had problems today. And you've seen the map that I've used in some of the videos. They are ahead of schedule, and they changed some of the scheduling, and we'll take a look at that before this video is over. But look at the distortions in our planet shields. It's amazing, especially northern hemisphere. That's where Cern is in Sweden. But it affects the Earth's entire magnetic shields. They go through the planet. That's how a compass works. In the top, out the bottom. They're represented in different models, but this type of distortion does not occur during normal solar activity. Even though those CMEs have not reached us, even in a side glancing blow, that is unusual distortion. That is man-made. Remember, Cern is the largest hadron collider. Atlas is the largest machine ever built on the planet. The magnetic energy that's developed at Cern Their energy is 100,000 times more powerful than this Earth's shield. So you can see how easily these two coils, as they're brought together through inductance, can transfer energy. You're dealing with a very large energy source when you're dealing with the sun. And guys, they are very aware. Look at those distortions. Take a quick look at this from a different angle. Notice the polar cap, the IMF, and the B field lines. The IMF are the blue lines. That's the interplanetary magnetic fields, basically the sun's magnetic field. The red lines are the closed sections of our shield, part of what's called the magnetopause. Now, you notice the blowback here? Also, as this increases, you'll see the front edge. You notice the sun's coming from the right. Notice the closed red loops. Right there, they're almost collapsed to the right side. Notice the timestamp today. UTC time at 4:45:50. Again, there is it right there. When that happens, there's a large amount of X-ray energy that penetrates the Earth. Cern is very aware of this. They have an instrument that's designed to detect this, and it has everything to do with exactly what they're trying to do, and that is create and open up a portal for dark matter. They're using what's called an axion detector. It's called CAST, C-A-S-T. We'll take a look at that. Again, as you look at this, notice the amount of energy that's blown back to the backside of the Earth, especially in the closed loops right there. Tremendous amount of energy. This is at 11:25 UTC time. As those shields collapse, that's what the Earth goes through. That's why if you're outside, I'm not sure about the entire globe, but in the southeast, the sun is very burning today because of that amount of X-ray energy that's penetrating the atmosphere now. This is the machine at Cern called CAST, Cern Axion Solar Telescope. This, they started September 19th. And that was a time-lapse video of CAST following the sun in the morning and in the evening. And again, September 19th. Over the next 10 days, CERN's Axion Solar Telescope, or CAST, will receive the sun's rays. The sun's course is visible from the window in the CAST Experimental Hall just twice a year, in March and September. The scientists will take advantage of these few days to improve the alignment of the detector with respect to the position of the sun to within a thousandth of a radian. Outside of this alignment operation, CAST tracks the sun but does not see it. The astroparticle experiment is searching for solar axions, hypothetical particles that are thought to interact so weakly with ordinary matter that they can pass through walls unimpeded. Sounds like dimensions we've read about in the Bible, passing through the walls. It says if they exist, axions could also be good candidates for the universe's dark matter. Dark matter is thought to represent 80% of the matter of the universe, but its nature remains unknown. Maybe it's supposed to remain unknown. When we were cast out of the garden, we were told we had a certain time before we would see the other side. And it goes on to say that they have yet detected the solar axions, but that they have established the most restrictive limit on their interaction strength. The experiment has therefore become a global reference on the subject. Again, the largest machine ever created. Now, CAST has been mentioned several times on another page, and you've seen it before. And it's in Revelation 12, and the great dragon was cast out, the old serpent called the devil and Satan, which deceiveth the whole world. He was cast out into the earth, and his angels were cast out with him. I heard a loud voice saying in heaven, Now has come salvation and strength in the kingdom of our God, and the power of his Christ, for the accuser of our brethren is cast down, which accused them before our God day and night. And they overcame him by the blood of the Lamb and by the word of their testimony, and they loved not their lives unto the death. Therefore rejoice, ye heavens, and ye that dwell in them. Woe to the inhabitants of the earth and of the sea. For the devil is come down unto you, having great wrath, because he knoweth that he hath but a short time. They know what names to use, and certain things cannot be hidden with discernment. seen the video that they made themselves. Remember the Cern video where they opened the portal and the demons came in? Remember that? Discernment will open your eyes every time. Study. This is a diagram of what they're talking about. Axions theoretically coming from the sun, catching into this X-rays and being pulled into the Earth's magnetic field. Cern interacts with that magnetic field. Those are the shields. In the Japanese model, you've got an axion coming in from the right, a magnetic field, converting that to light. Remember luminance, that's what they're trying to achieve, not our light. Now, this is why we cannot go by their calendars. This is what, but again, it's a year old and they've had breakdowns, shutdowns, restarts, the entire 9 yards. But the special physics run that they're about to start up soon was not scheduled. This one was scheduled back September 31st through that week. But we're now in week 42, right there on the 14th. I'll explain that. The dates go down the side, the months across the top, and the weeks across the top. But notice at the top of this column, it's the 12th, 13th, 14th, 2 down. We're technically supposed to be in a scrubbing run. Then right there, on November the 16th, it says the ion setup, and this is for gold collisions, much heavier particles, much hotter temperatures, much denser particle collisions, creating plasma. But again, they may be ahead of the schedule. But in this diagram, A is where beam 1 and beam 2 are approaching at near the speed of light. B is the collision, C is the plasma created, and D is the scattering of particles, and their different particles have been created. That's what they're looking for, this dark matter. Again, in that model, it says 2 heavy gold nuclei flatten into a pancake shape. Since they're traveling near the speed of light, they collide head-on during that collision. That's what you see. Again, the white particles were new ones. But they're saying these accelerators are making head-on collisions between massive ions, such as gold or lead nuclei. In the ion collisions, the hundreds of protons and neutrons smash into one another at energies upward of a few trillion electron volts. This forms that plasma I'm talking about. It instantly cools, and the individual quarks and gluons, collectively called partons, recombine into a blizzard of ordinary matter that speeds away in all directions. The debris contains particles such as pions and kaons, which are made of a quark and anti-quark, protons and neutrons, made of 3 quarks, and even copious anti-protons and anti-neutrons, which may combine to form the nuclei of anti-atoms. To me, it seems they're trying to reverse engineer what God did when he closed that veil, guys. Not to be reopened until Christ steps his foot back here. Man does not need to mess with this. Again, they are down now. For the last few days, they've been running very heavily, strong. You've seen it. This is what it looked like when they dumped both beam 1 and beam 2 as they were spiraling. You lose magnetic control, you're going to have that. But notice here, in the coordination planning, now they're up to 2,000 nominal bunches. Again, 25 nanosecond intensity ramp-ups at 6.5 tera-electron volts per beam, 13 TeV. Again, that special physics run is not scheduled. We're here at October 14th. The last one was September 31st. Special physics run setup. See that until Friday. They're ahead of schedule. Are they taking advantage of this increased energy coming from the sun at this point? They've been running very high levels for very long periods of time. What we need to watch in the next few days is as the sunspot comes around, Cern's running hot, watch for increased filament eruptions and solar flares. And every time you're going to see an increase in earthquakes. They've been very quiet. The sun's been very quiet. We're watching it, guys. It's very interesting times. It's a heads up. Be safe.